Hello everyone. Today we are going to start with a new topic that is pipelining. So we are going to see the introduction part of pipelining. And before getting into that pipelining topic, let's see one topic that is parallel processing. Okay. So what is parallel processing? Parallel processing is a technique in a computer science where multiple processor or a core execute different parts of the program simultaneously to solve a problem faster. Okay, what does it mean is there would be one program. Okay, this program might be written by a programmer. Okay, and what happens when that programmer start to execute that program, then what happen exactly is there would be multiple processor. Okay, like processor 1, processor 2, processor 3, or you can call it as a cpu 1, cpu 2, or cpu 3. They all start to execute. Okay, they will all start to execute this one program. Okay, and how they do is this particular program will be divided into three parts. Okay, because we have three processor, right? So it will divide it into three part, and one processor will take care of this particular part. Another processor p2 will handle this particular part, and p3 processor 3 will handle this particular part, and all these processor will work parallelly. Okay, and at different parts of the program, and try to execute this one program p1. Okay, this one program 1. Okay, this is how they work. So all the processor will come together and execute one program. Okay, and that is what a parallel processing is, right? Now you can see when you're using this multiprocessor, then every part of this program is executed by different processor. So execution will be very faster because of this parallelism, right? Now because of this multiprocessor, your cost of your CPU or your cost of your computer will be very high. Okay. Now suppose your computer is designed in such a way that there is one program, right? Okay, one program means one program is executed, and it is handled by only one processor. Means inside your computer there is only one processor, there is no multiple processor. So if you try to write one program, that entire program will be executed by only one processor. Okay, now this is the situation. Okay, here in this parallel processing we had multiple processor which were working on one program. Here we have only one processor which will work on this entire program. Okay, now there is no parallelism, the execution will be very slow compared to the parallel processing. But I want some technique which will mimic or which will simulate the same parallel processing. Okay, using a one processor, only using one processor. I want to maintain the parallel processing using only one processor. How it is possible? So for that thing, okay, to mimic that technique of parallel processing, we have one more technique that is called pipelining. Okay, so there where the technique called pipelining come into picture. Okay, so when we have one processor, okay, and it wants to mimic or it wants to simulate the same parallel processing technique, then we can use the technique called pipelining. Okay, so why we need all this technique is to improve the CPU performance. That's it. So we want to improve a CPU performance. Okay, so for that purpose we are doing all these techniques, right? So I hope you understood why we need a pipelining. So in this next lecture I will cover about pipelining technique. Okay, fine.